Alright, today we're going to look at temperature and energy and also how they relate to one another. Now, this is just the definition of temperature. The temperature of a substance is proportional to the average kinetic energy of the substance's particles. And we've talked about this before. If particles are moving a lot, then the temperature is higher. When we lower the temperature, the particles start to move less, which is what kinetic energy is. All particles have kinetic energy. And immediately you may say, well, no, solids are not moving. But remember, solids slowly vibrate, so slowly that we can't see them. So they do have kinetic energy, it's just very, very low. All particles in a substance are constantly moving. As the average kinetic energy of the particles in an object increase, the object's temperature also increases. And this is just a review because we talked about this in Unit 1, but as you increase temperature, you increase kinetic energy. Now, common thermometers actually rely on expansion, and thermostats rely on the expansion of different metals. Most metals expand when they're heated, and they contract when they're cooled. And so what that does is, if you've got a thermometer in your mouth and you've got a high temperature, as your temperature goes up, the metal's going to expand, which raises the thermometer, raises the temperature on the thermometer. Thermostats do the same thing. When it gets hotter in your house or more warm in your house, the metals expand. When it cools down, which is going to cut on the air if you have the air on, when it cools down in your house, the metals contract, which is going to cut that air off. And that's how it knows when to cut on and when to cut off. Now, we have 3 different temperature scales that we're going to work on and use in our class. It's the Fahrenheit, Celsius, and Kelvin temperature scales. And these are commonly used around the world, and it depends on what you're using them for is going to determine which scale you need. Now, Kelvin is going to be the one that we use the most in science. Well, I say that. I probably shouldn't say the most. Celsius is used a lot also. So Celsius and Kelvin we're going to use the most in science. Fahrenheit is what we use in the United States, but it is not used around the world. And Kelvin is more of a scientific scale. Now, the Fahrenheit and Celsius scales are 2 different temperature scales. Don't think that they're the same, and we're going to look at their differences. The Fahrenheit scale, the units on the Fahrenheit scale are called degrees Fahrenheit. And on the Fahrenheit scale, water freezes at 32 degrees Fahrenheit, and it boils at 212 degrees Fahrenheit. The temperature scale most widely used in science is the Celsius scale. Now, let's look at more detail of the Celsius scale. The units on the Celsius scale are called degrees Celsius. And on the Celsius scale, water freezes at 0 degrees Celsius and it boils at 100 degrees Celsius. And you're going to need to know these 2 types of things with the Fahrenheit scale and the Celsius scale. Now, if I'm given temperature in Fahrenheit, but I need to go to Celsius, or you're visiting in Europe and they are giving you Celsius and you want to convert it to Fahrenheit so that you can figure out what you need to wear for that day, that's what we're going to learn now. If you're going from Celsius to degrees Fahrenheit, you're going to take the Celsius temperature you have, multiply it by 1.8, and then add 32. And that's going to give you the Fahrenheit temperature. If you're wanting to start with Fahrenheit and go to Celsius, then you're going to take the Fahrenheit temperature minus 32, and you're going to calculate that first, and then divide that answer by 1.8, and that will give you the Celsius temperature. Okay, this is what I'd like you to do. You have 2 practice problems in your notes. I would like you to pause the video, complete those practice problems, and resume the video when you're ready to check your answers. All right, number 1 is 41 degrees Fahrenheit, and number 2 is negative 15 degrees Celsius. And this was just plugging numbers in, But if you have a question about it, make sure you write it down on the side of your notes so that we can talk about it tomorrow. And we'll do plenty of practice with this in class. Okay, now let's talk about the Kelvin scale. The Kelvin scale is based on absolute zero. And a temperature, remember that temperature is a measure of the average kinetic energy of the particles. The theoretically lowest temperature is negative 273.15 degrees Celsius. And that's called absolute zero because at this temperature, no particles would be in movement. Nothing would be in movement. So let's look. At a temperature of absolute zero, the kinetic energy of an object would be zero. And on this scale, 0 Kelvin or 0 K, that's K is what we use to abbreviate for Kelvin, 0 Kelvin is absolute zero. Now, there are no negative temperatures on the Kelvin scale. Fahrenheit and Celsius can have Kelvin, Fahrenheit and Celsius can have negative, but Kelvin cannot. Now, let's look at the conversion equation. If you have Celsius and you need to go to Kelvin, you simply add 273 to the Celsius temperature. If you have Kelvin and you need to go to Celsius, you take the Kelvin temperature, subtract 273, and it gives you Celsius. Now, obviously, if you'll notice, you can't go straight from Fahrenheit to Kelvin. So what you have to do is if you need to go to Kelvin or get the Fahrenheit from Kelvin, then you have to change it to Celsius before you can convert it to then Kelvin or Fahrenheit. So if you have Fahrenheit, you would change the Fahrenheit to Celsius and then change the Celsius into Kelvin. So it would be a two-step problem. If you have Kelvin, then you would change it to Celsius and then Celsius to Fahrenheit if you're needing to go to Fahrenheit. Most of the time, you're going to be converting between Kelvin and Celsius. Let's go ahead. I want you to do practice problem number 1 and number 2. Pause the video and resume the video once you're ready to check your answers. All right, number 1 is 278 Kelvin, and number 2 was 261 Kelvin. If you have questions about these, make sure you write them down so we can talk about them tomorrow. And like I said, we will be doing a lot of practice with these in class. Okay, for today's summary, I would like you to write down the word energy and use it as an acrostic. And for every letter in energy, I want you to give me a summary. Like each letter needs to represent a part of the video. I hope you have a great evening, and I'll see you in class.